Francis, what's your favorite color?
Pink.
Black.
Pink.
Francis.
White.
Helping.
That's tricky. What? Okay. I just wanted a different color. That's all that was it.
What if your favorite color is white?
Then I would have done something, I don't know.
Yeah.
Oh, birds!
Yeah, Trevor.
I was just rude in general. I said that.
Trevor. Use the presence of all color.
Oh, that's orange. Sorry, Francis. There you go. There you go. All right. So if I have a position versus time graph, not my best work. What can I get from that graph? What information can I glean from that graph right now?
Constant velocity.
How do I know that? What am I analyzing? Mark?
Slope.
What? The slope.
Oh, I thought you were raising your hand. You were pointing. Okay. Good. So the slope is what? Slope is the what on that graph? Oh, that's not what I mean. But yeah, for you guys, yes, I wrote the left thing. The slope of an x versus t graph tells me what? The velocity. Very good. The slope of x versus t is the average velocity. Okay, we should already know that, hopefully. To find slope, we should be doing the final position minus the initial position divided by the final time minus the initial time. It's going to be written in shorthand as the change in x over the change in t. What's another word for the change in position? What's another word for that? Displacement. So this could really be written as displacement over time, which equals velocity. This is your first official equation in physics. Yay. Woo-hoo. That's called the average or constant velocity equation. So that equation is going to be used when the velocity is constant. Only when the velocity is constant. When the velocity is constant only, and banging for emphasis, this equation can be used. So let me ask a question. If an object is accelerating, Courtney, can I use that equation? Perfect answer. I stress that because some of you, what happens a lot of times in here on tests and such, you guys will get confused and start doing something, which is admirable, but they start doing the wrong thing sometimes. And so I'm trying to emphasize only, so if there's gravity involved that causes things to speed up, if anything speed up, don't use that equation, only when it's constant velocity. You also, during the year, you don't need to memorize these equations. You'll write them down on paper before the test and such, so don't stress over that. Okay, first equation, velocity equals displacement over time. Good?
Good.
Besides slope, there's some green here. Besides slope, what else about a graph can I analyze? That's okay. I don't know if you would know the answer. There's two things of a graph we'll analyze: the slope and the area. So this is kind of like number 8 now. So we want to look at perhaps maybe the area of this graph. And so this graph, let's just make up numbers here. Let's say this is 2 meters per second. Let's say this is 4 seconds. Let's say this is 6 seconds. This is 9 seconds. Let's say this is down here negative 4 meters per second, right where this C is. Okay? So I want to try and find the area of those segments and see if they tell me anything interesting. I bet they're going to. Hope so. It's kind of useless. So I'm going to find first this area. What's the area? If you haven't learned this stuff yet, I don't know exactly where in math you learned this. Area refers to the area between the graph and the x-axis. So the area of A would be right there. Why don't I find the area all the way down here too?
You need traveling.
What's that? Okay. if I keep going down past the x-axis, I really have nowhere to stop. And so in reality, I'm going to find the area all the way down to negative infinity, which will always be infinity and be somewhat useless to me. So I always stop at the x-axis. So don't do that part down there. Why won't you? There. So I find this area. So that area, what's the area of a rectangle?
Base times height.
Base times height. That's going to be 2 meters per second times 4 seconds. What's that equal? 8 what?
8
Meters. Seconds cancel out. 8 meters. What is 8 meters? What kind of number is that? Remember a D word?
Adjustment.
Displacement.
Displacement.
So the area under the velocity graph seems to come with the displacement of the object is. Okay? So area, very interesting. The area of V versus T is displacement.
VVT.
Which should make sense, right? I'm taking velocity times time and getting displacement, which is really just that other equation, right, rewritten with D by itself. So it shouldn't be earth-shattering, but you can see hopefully how those things all tie together in that sense. Good?
Yep.
Okay, let's find this area. Again, you go between the graph, the line, or the curve, and the x-axis. So what's that going to be? What times what?
4 times 3.
Negative 4 meters per second. Make sure we include units in our work. Times 3 seconds will be negative 12 meters. And that is why we know that C on your paper, number 8, C appeared to be a bigger area than did A. That's how we know that C was a greater displacement than A was. And the numbers, if you made them up, I guess I made them up on purpose that way, but the numbers would bear that out as well.
Is that negative 12?
Negative 12, it was a negative velocity.
Got it.
So now you have negative areas. If that rocks your world, sorry. It rocked my world when I was in high school. I was like, the negative area, what does it even mean? But it's just a different direction. A 3D graph with negative volume just blows your mind. So, questions about that? I victory dance. I win. Okay, I'd like you to sign up for a question off the new homework, the whiteboard. Make the whiteboard. We're not going to go over them today, but take them, make a whiteboard, put it back in the cabinet.
Go. Get one. Get one. One. Get 4. Yeah. One or 2. And number 2. Yeah, 1. Yeah, do 1. Do 1. Do 1. Perfect. Nice job, Brian.